In this section, we're going to talk about linear functions versus nonlinear functions. And so just a reminder that a linear function is a function whose graph is a line, and a nonlinear function is not a line. So if you were looking at a table or a graph, the graph you can see whether it's a straight line or not, but in a table, we would say that a linear function shows a constant rate of change, and a nonlinear function does not show a constant rate of change, so it is not a line. So here we go. We have two tables, and we can see, are they linear or not? And so you check out the x values first, and you can see on this that 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. That's a constant change. On the bottom, if you take 40 minus 32, you get 8. So it goes down by 8. If you do 32 minus 24, the question is, do you get 8 again? So each one of these has to be the same. 32 minus 24 is 8 again. 24 minus 8 is 16. So this is constant and this is constant. So it is, yes, it is linear. Okay, so what about this? We go up by 2. 1 plus 2 is 3, plus 2 is 5, plus 2 is 7. How much do we go up here? So if I go from 2 to 11, I went up 9. If I go from 11 to 33, I went up 22. If I go from 33 to 88, I went up 55. So these ones are constant, but these ones down here are not. So this is not linear or non-linear. If we were to graph that, it would not be a straight line. On this one, you're just looking at the graph and telling me, is it a straight line? That one's definitely not straight. It's got two curves in it. So this is non-linear. This one over here, though, this is a straight line. If you have a straight line there, then this one is linear. So you can see that when you look at a graph, it's very easy to tell. A table is just a little bit harder. All right, so now you have two tables and a graph for yourself. Push pause, get your answer, and then come back and check it. All right, for number 1, we have a constant rate of change on the x and a constant on the y, so yes, this is linear. On number 2, we went up by 2's, and here we went down by 4's. This is constant, so yes, it is also linear. For number 3, we have a straight line, but it bends right there and comes straight back down. So this one is not a straight line, so it is non-linear. This one's actually called piecewise linear because it does have two straight lines, but it's not completely linear. Last part is identifying nonlinear functions from an equation. And remember, in an equation, a linear equation is represented by the equation y equals mx plus b. If it's in this form, then it is linear. So when we look at each of these, part A, y equals 0x plus 4.7. This one is in the form of mx plus b. There just doesn't happen to be an x in it. For part B, we have y equals 3.14x plus 0. This one is also in the mx plus b format. There just doesn't happen to be a b on the end of it, and the m is pi. Letter C, y equals 4 times 1 over x plus 0. This one is not in the form of mx plus b. There's no way we can put this so that we have x times a number because the x is in the denominator. So this one is nonlinear. Looking at D, though, y equals 4 times x minus 1. If we did the distributive property, we could get 4x minus 4. So it is in the form of y equals mx plus b. So this one, C, is nonlinear. Here's 3 for you to try. Push pause and then come back and check your answers. So number 1 is in the form of y equals mx plus b, so it is linear. B, when we, 5, when we write this out, we could do 4/3 times x plus 0. So this one also is in the correct form, so it is linear. Number 6, though, this one says y equals negative 1x squared plus 1. This has a square in it. That is nonlinear because it has to be y equals mx, mx with no power. So this one is no, it is non-linear.